To calculate the electrical load for common areas in a condo building, you'll need to follow a systematic approach. This includes hallways, parking garages, and elevators. Firstly, determine the area of the common areas. Measure the square footage of the hallways, parking garage, and elevator. Accurate measurements are critical for a precise load calculation. Secondly, calculate the unit load. Determine the unit load in watts per square foot for the individual units. This information can usually be obtained from the local building code or from previous energy studies conducted on similar buildings. Unit loads reflect the expected power consumption per square foot and vary depending on the type of area. Thirdly, multiply the area by the unit load. Multiply the area of each common area, which you determined in the first step, by the unit load, which you determined in the second step, to estimate the electrical load for that specific area. For example, if a hallway has an area of 500 square feet and the unit load is 3 watts per square foot, the hallway load would be 500 square feet times 3 watts per square foot, which equals 1500 watts. Fourthly, sum the loads. Sum the loads calculated for each common area to obtain the total common area load. This involves adding up the individual loads for hallways, the parking garage, the elevator, and any other common spaces. Fifthly, apply a diversity factor, although this step is optional. A diversity factor can be applied to the common area load to account for the assumption that not all lights and appliances will be operating simultaneously. Typically, a diversity factor of 0.5 is used for common areas. However, the diversity factor can vary depending on the type and usage of the common areas. If specific usage data for the common areas is available, it can be used to refine the load calculation. The common area load formula is as follows: common area load equals the sum of common area multiplied by the unit load, all of that multiplied by the diversity factor. Remember that the diversity factor can vary depending on the type and usage of the common areas. If specific usage data for the common areas is available, it can be used to refine the load calculation. Consulting with an electrician or energy auditor is recommended to ensure an accurate load calculation. The more data you can gather about a location, the better your calculations will be. To ensure you are using the proper calculation for the condos, you should determine the square footage of each of the common areas such as hallways, parking garages, and elevators. This will be used in subsequent calculations. Building codes typically specify minimum unit loads for various types of occupancies. You'll need to identify the appropriate unit load in watts per square foot for the common areas in the condo building. This might differ based on the specific use of each area, such as hallways versus parking garages. Multiply the square footage of each common area by its corresponding unit load to determine the estimated electrical load for that area. For example, if a hallway is 1000 square feet and the unit load is 3 watts per square foot, the load for the hallway is 3000 watts. Add up the individual loads for each common area, such as hallways, parking garages, and elevators, to obtain the total estimated load for all common areas. Apply a diversity factor to the total load. The diversity factor accounts for the fact that not all electrical equipment in the common areas will be operating at full capacity simultaneously. A typical diversity factor for common areas is 0.5, but this can vary depending on the specific usage patterns. If the total calculated load for the common areas is 10,000 watts and the diversity factor is 0.5, the adjusted load is 5,000 watts. Consider any large or specific loads in the common areas, such as HVAC systems, elevators, or specialized equipment. These loads should be calculated separately and added to the total load. Elevators have specific power requirements for their motors and control systems. Obtain the nameplate data for the elevator motor to determine its full load amperage and voltage. Use this information to calculate the power consumption of the elevator. Include the elevator load in the overall common area load calculation. Parking garages may have specific lighting requirements for safety and security. Calculate the lighting load based on the number and type of light fixtures used in the parking garage. Include this lighting load in the overall common area load calculation. Consider the power requirements for any HVAC systems that serve the common areas. Obtain the nameplate data for the HVAC equipment to determine its power consumption. Include the HVAC load in the overall common area load calculation. You may consult with an electrician or engineer. Engage a qualified electrician or electrical engineer to review your load calculations and ensure they meet local electrical codes and standards. They can also provide guidance on selecting the appropriate size of the electrical service for the building. Keep in mind that electrical codes and standards can vary by location. Check with your local building department or electrical inspector to ensure compliance with all applicable regulations. Be aware that the National Electrical Code, or NEC, provides guidelines and requirements for electrical installations. Familiarize yourself with the relevant sections of the NEC that pertain to load calculations and service sizing. Accurate load calculations are essential for ensuring the safety and reliability of the electrical system in the condo building. Underestimating the load can lead to overloaded circuits, power outages, and potential fire hazards. Overestimating the load can result in unnecessary expenses for larger electrical equipment and infrastructure. When determining the area of the common areas, be sure to include all spaces that are used by multiple units or tenants. This may include hallways, lobbies, stairwells, laundry rooms, recreational facilities, and other shared amenities. Use accurate measuring tools such as a laser distance meter or measuring tape to determine the dimensions of the common areas. Double-check your measurements to minimize errors. If the common areas have irregular shapes, divide them into smaller, more manageable sections for measurement purposes. Calculate the area of each section and then add them together to obtain the total area. When determining the unit load for the common areas, consult with local building codes, electrical inspectors, or experienced electricians. They can provide guidance on the appropriate unit load values to use based on the specific types of common areas and their intended uses. If energy studies or historical data are available for similar condo buildings in the area, review them to gain insights into the typical electrical consumption patterns of common areas. This information can help you refine your unit load estimates. Consider the types of electrical equipment and appliances that are likely to be used in the common areas. For example, hallways may primarily use lighting, while laundry rooms may have washing machines and dryers. Adjust the unit load values accordingly to reflect the anticipated electrical demand of these devices. When multiplying the area by the unit load, ensure that you are using consistent units of measurement. If the area is in square feet and the unit load is in watts per square foot, the resulting load will be in watts. Be meticulous with your calculations and double-check your work to avoid errors. Even small errors in the load calculation can have a significant impact on the overall service sizing. When summing the loads for all common areas, create a detailed spreadsheet or table to keep track of each individual load and its corresponding area. This will help you organize your calculations and ensure that you don't miss any areas. Include all common areas in your load calculation, even those that may seem insignificant. Every electrical load contributes to the overall demand on the electrical system. When applying a diversity factor, consider the usage patterns of the common areas. If the common areas are used sporadically or only during certain times of the day, a high diversity factor may be appropriate. If the common areas are used continuously or have a high concentration of electrical equipment, a lower diversity factor may be necessary. Consult with an experienced electrician or electrical engineer to determine the appropriate diversity factor for your specific situation. They can assess the usage patterns of the common areas and provide guidance on selecting a diversity factor that accurately reflects the anticipated electrical demand. If you have access to historical energy consumption data for the condo building or similar buildings, analyze the data to identify peak demand periods and usage patterns. This information can help you refine your load calculations and diversity factor selection. When calculating the loads for specific equipment, such as HVAC systems or elevators, obtain the manufacturer's specifications or nameplate data for the equipment. This information will provide you with accurate values for the equipment's voltage, amperage, and power consumption. Use the appropriate formulas to calculate the power consumption of the equipment based on its voltage and amperage ratings. For example, for single-phase equipment, the power consumption in watts is equal to the voltage in volts multiplied by the current in amps multiplied by the power factor. For three-phase equipment, the power consumption in watts is equal to the square root of 3 multiplied by the voltage in volts multiplied by the current in amps multiplied by the power factor. The power factor is a measure of how effectively the electrical equipment uses power. It is typically expressed as a decimal between 0 and 1. If the power factor is not provided in the equipment specifications, you can assume a value of 0.8 for most electrical equipment. Consult with an electrician or electrical engineer to determine the appropriate power factor to use for your specific equipment. When determining the size of the electrical service for the condo building, consider the voltage and phase of the service. The voltage and phase of the service will determine the types of electrical equipment that can be connected to the service. Common service voltages for condo buildings include 120 volts, 208 volts, 277 volts, and 480 volts. Common service phases include single-phase and three-phase. Select an electrical service that is appropriately sized to meet the calculated load of the condo building. The service should have sufficient capacity to handle the peak demand of the building without overloading. Consider future growth and expansion when sizing the electrical service. It is generally a good idea to add some extra capacity to the service to accommodate future electrical loads. Work with a qualified electrician to install the electrical service in accordance with all applicable codes and standards. The electrician will ensure that the service is properly grounded and protected from overcurrents and short circuits. Obtain all necessary permits and inspections from the local building department before installing the electrical service. The building department will verify that the installation meets all applicable codes and standards. Keep accurate records of all load calculations, equipment specifications, and service sizing information. These records will be helpful for future maintenance, repairs, and upgrades to the electrical system. In addition to calculating the electrical load for the common areas, it is also important to consider the electrical load for the individual condo units. The electrical load for each unit will depend on the size of the unit, the types of appliances and equipment used in the unit, and the lifestyle of the occupants. Consult with the building owner or property manager to obtain information about the typical electrical consumption patterns of the condo units. You can also conduct energy audits of the units to assess their electrical loads. Add the electrical loads for the individual condo units to the electrical load for the common areas to determine the total electrical load for the building. This total load will be used to size the electrical service for the building. In addition to the NEC, there may be other local or regional electrical codes and standards that you need to comply with. Be sure to check with your local building department or electrical inspector to ensure that you are following all applicable regulations. If you are not familiar with electrical load calculations and service sizing, it is best to consult with a qualified electrician or electrical engineer. They have the knowledge and experience to perform these calculations accurately and ensure that the electrical system is safe and reliable. Remember that electrical work can be dangerous. Always take precautions to protect yourself from electrical shock and other hazards. Turn off the power before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment. If you are not comfortable working with electricity, leave the work to a qualified electrician. By following these steps and guidelines, you can accurately calculate the electrical load for the common areas of a condo building and ensure that the electrical system is properly sized and installed. This will help to provide a safe, reliable, and efficient electrical service for the building and its occupants.